really. Explicitly told it to use the east const and to end comment with a dot or a period. But no. Every AI is failing at that. Run over all intervals. If the interval does not need a subdivision, push it back to the new intervals and go to the next one. Otherwise, oh, that's gonna copy a shitload. Double midpoint. The interval start plus interval n divided by 2. And the sign is, of course, sign of the derivative of that mid. It's completely ignoring my formatting request so far, as in I explicitly say that it has to use full English words, not abbreviations. And there we have mid. New intervals, push back. Mean adjacent length. What is mean adjacent length? Why is it starting at 1? I can't even follow it, and it hangs, so it's not working. I think I'm gonna give up on trusting AI to code this. Just make up ourselves something ourselves. I'm gonna make up something myself. Okay, let's see. Interval, can we keep this? I guess. I don't think this is needed. I mean, this just makes things more complex. And it's another hard-coded value that might make no sense under certain circumstances. Okay, now to think of something like how to do this. So we have a interval, and the interval has a sign for the derivative, which is either positive or negative, and we know that at the edges. For example, it's positive there and it is positive there. If this is the very, very first interval, then, well, we don't know anything except that the start and the end sign of the derivative is the same. So then the next thing that we want to do is determine what is the sign of the derivative in the middle of this. Now let's say that is also positive. Then I'm going to say we did split the interval in two, and the end of this interval is a sign of a derivative obviously equal to the sign of a derivative of the begin of the next interval. So there is only one derivative sign here, even though we have two intervals. That already makes this very dubious-ish, I would say, but okay. Now you could say, well, I can view both of these cases separately. I have just an interval here with the same signs and the same here. So we have to do the exact same thing again. But that's not true, because in this case it was the very, very first time. And in this case we know that we already divided it once. Okay, only once. So maybe we should have a counter. Let's call that counter depth. I'll put it here. So in this case, the depth is 0. In this case, the depth is 1. Now I'm actually going to do the same thing, which means that we are dividing this one in two. And we're going to divide this one in two. And the depth for both goals is 2. Now assume that this one is also positive, and this one is also positive. Then I'm going to assume that there are no minimum. Why? Because let's say we're an absolutely random function. The chance for this the sign at an arbitrary point, like in the middle of wherever, is 50%. So the chance that there is anything negative here in between these two is kind of like a half times a half times a half, I think, which is reasonably small. I could maybe put a restriction on the total, the maximum width. So if this is indeed the original interval, then I might say, well, let's divide it again, because this is the complete interval. And so we have a certain we have a maximum interval size, and I could start with setting that maximum interval size immediately as being not a quarter of the total interval size, but of, say, a 16th or something like that. So a 16th would be let's say this distance. So maximum, well, maximum minimal. Let's call it not maximum minimal, but maximal stop interval size. Well, that doesn't change, I think, here. And that didn't change here. So in this case, I would divide it again, because these intervals are not, and all of the intervals are larger than the minimum, than the maximum size. So we're going to divide this again into and I'm just stubbornly assuming that the derivative is positive everywhere. And still they are larger than that maximum stop interval, so oops. We're going to do it again. And again we find okay, let's put a 1, 2, 3 in between. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Right, so here we stop. And then these are the intervals, and then I can process further as being having no sign change at all. I do. But of course, we could run into a minus sign somewhere. Let's say, so the first one is positive, the next one gives me a minus sign. I'm just gonna put it in, I guess. Let's say this one is a negative. Let's keep this on positive for now. Now what? Now we have to subdivide all of them because this interval never gets larger, it only gets smaller. So definitely go and subdivide them again. And then say we measure a minus here and a plus there. And this one is also a plus, and this one is also a minus. Shocking. And then we divide them again. I need a random generator now, I think. No, let's make up the original function. Let's say the original function is plus minus 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 plus 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 minus 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 plus 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 minus 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 plus 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 plus. Yeah, that corresponds. This plus is that plus here. And this one is a plus. And this one, oh, there's now a plus, but I wanted it to be a minus. And then this one is, it also didn't go well. And this one is a minus. Yep, the rest is okay. Then after subdividing it again, because they, well, usually have to go to 1/16 at the very least, I'm getting here a plus, and here a minus, and here a minus, and here a plus, and here a plus, and here a minus, and that's a plus, and that's a minus, and this is a plus. Now all intervals are less than this one, but I'm not stopping because I only stop when there are at least 4 times the same sign on a row, where the distances are all less than or equal a quarter of the distance between the outer part. So actually this is not even enough. I have 4 here, but for all we know, it's immediately here next to it, it is a plus, and here as well. So the only thing we know that the width here is this size. And a quarter of that is still smaller than the size between these things. So here as well, we have an adjacent distance. No, we don't have that, don't have that. Now this in turn means that the maximum stop interval is actually something that is part of this adjacent thing. So we have one for this one, and you have another one for that one, and another one that one, and well, that one is empty. So dot. Okay, let's put that in the mix. This means that here we have two of them, which means that we have this width of adjacent pluses with an 1/16th of that as the maximum stop interval. So I put this one here. In this case, you have the exact same width and still 1/16th of that because it can't grow. In this case, this turned into a dot. This turns into a dot. And this one is this big. And that means that let's just put it a little bit to the left to where I can recognize that it is part of that interval. Well, yeah, no, maybe, no, actually no. Just have to. This dot does belongs to that dot, obviously. Empty intervals. Now here I want to use 1/4 of the above size. So does this width divided by 4, but it can't be larger than that one. So it is again reduced to the previous size. And here I have this. This one gets smaller because we have only this, so I want to use a quarter. So this is a quarter of that size. And then here we also have a quarter of that. And here we have a quarter. Well, I don't know, doesn't really fit. Let's say that's a quarter. This one is empty. This one's empty. So here I would say this interval is larger than this interval, therefore we divide it. Same here, same here. What do I do with this? I probably have to first, I have to wait with this. I have to first do the ones that are equal until we stop with that. So we don't divide this at the moment because the intervals on the left and the right still have to be divided. Same here, and yeah, everywhere actually. So all intervals are divided again. And this can't grow. It's not actually true. This one would grow. Just a quarter of that thing. Because the only thing that it can't grow larger as is the 1/16th of the total. For the rest I just want to use, there is no limit. But okay, this one was 1/4 of that length, so that didn't change then. And here, well, we get something that is indeed larger. Because we need something like this, 1/4 of that. Call that 1/4. Now, as you can see, the intervals are still larger than everything, than the stop intervals, so they are divided again. Hopefully that exactly works out, and it does. It's definitely the last time I can do this. Oh, wait a minute, wait. I was not going to do that one. Likewise, I was not going to do this one. Not immediately. So this actually does not exist yet. Okay, that's problematic because I think it would be nicer to divide it. Then we just know if left or right is growing. I think we should have that. We should do that. Yeah, we should do it. So it's more like I divide this interval in two because the left and right have to be divided as well. If even one of them has to be divided, then we divide it. That's a good rule, I think. forgot to increment my depth, but I have the feeling that the depth is no longer relevant. Let's remove the depth. Okay, so maybe I should have kept this at the bottom so you can more easily see what it should be. So that's a quarter. 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6, 7. So it's, I don't know, something like a quarter of that, something like this. Yeah. And here a quarter is also something like that. And here a quarter is really tiny. Less than 1 character. Right. So now what happens is that we do not divide this interval because it belongs to that series. And the size of this interval is less than a quarter of that. In other words, we have 1, 2, 3, 4, 5 of them in it. And the same here, 1, 2, 3, 4, 5, 6, 7, 8. So that's more than 5 even. So this one is, these intervals are not divided. These intervals are not divided. And therefore we don't divide this interval here in between that. And here also a lot of those. Therefore we don't divide that one. But here we are going to divide it because it's this distance is definitely larger than 1/4 of it. So instead of looking at 1/4, I can simply count the number of borders, I would say. So I just count the number of intervals. It's probably smarter. So here we have 1, 2, 3, 4 intervals. 1, 2, 3, 4, 5, 6, 7 intervals. 1, 2, 3, 4, 5, 6, 7, 1, 1, 1, 2, 3, 1, 2, 3. So we do not divide this, we do not divide this, because 4 and 7 are greater or equal 4, and therefore we also don't divide the thing in the middle. And here I'm dividing this one and therefore also that one. So I'm adding extra measure point here. Keep that one, divide that one, keep that one, divide that one. And also this, 3 is less than 4, so all of them are divided, like that. And the rest I can't show anymore, but by this time I hope I have my algorithm defined. Hi Mitchell. I haven't been streaming before, but I did indeed go. Actually, I went to sit on a terrace and had a cup of tea while it was raining, but I did bring my umbrella. And they had something above the table, so it was dry. Need to think of where to store this thing. I guess the depth does matter, or I can just immediately start with dividing it in 16 parts. It's probably the smartest thing. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 or something. So it just goes straight from here to there. Why not? And then I can count this as 1, 2, 1, 2, 3, 1, 2, 3, nothing. God, the whole thing is empty. 1, 1. Yeah, then I don't have any example of something that is being cut in 2. So let's pretend that we don't start with 16 at once, although we do. And then in this case I would have so nothing, 1, 2, and that then turns into 1, 1, 1, 2, and again nothing. So it is like this interval here is part of the same continuous range of pluses as that one. And then after finding this plus, then both this one and that one are part of the same thing. And this one and that one are no longer part of the same thing. Because, yeah, there's a minus sign here in the middle. I would prefer to have some object to point to though. So I would prefer that this interval here still points to some object that is kind of related to something like that. Is this per interval? Yeah, for example, in this case, this interval here between the plus and the minus must be aware of the sizes of these ones. So if this is an object, it should have a pointer that points to this object and a pointer that points to that object, left and right. Then this interval only points to this object. This interval only points to this object. So this one points to two objects. This one points to 1, 1, 1, 2, 1, 1, 1. And now this one is interesting. It points to that one, but there is nothing on the other side. I guess a null pointer. It's kind of the same as what happens here, I guess. Well, no, this just points there. This one points, let's say, if this was a minus, then this one would point there, but there's nothing on the other side, like literally not. Yeah, there was no interval there, so there's nothing to point to. This one does not own anything, even if it would exist. A null pointer is, I think, doable. So here we have a null pointer on that side. This one then has two null pointers. Just doesn't point anywhere. This one points null pointer to that side and points to this object on that side. This only points to that object. So there is a difference here. So I could use, I do not need two pointers, and I could use a union where either both pointers have a meaning because it's an interval that changes sign, or only the first pointer has a meaning because it's an interval that doesn't change sign. And then here again we have both. And then if I have to process this thing to go to the next level, I can just run over all the intervals. And then each interval has a size, of course, and a pointer to the thing above it. So I just ask this thing, how many do you have? And if it says 2, then I divide it in 2. Same thing here, and so on. And then, for example, in this case, this interval has a pointer to this object, and it says, how many do you have? It says 4. Okay, then we don't divide ourselves. Go to the next one, don't divide, don't divide, don't divide. This one is a different beast. It has a plus and a minus, so it asks both that one and that one. Both are larger than 3, so doesn't divide itself. And so we can continue until we get here. And then that one says 7, and that one says 1, which is less than 4, and therefore this one does divide itself. So that way each interval can decide for itself, breadth first, if it wants to divide it or not. And then after I decided if it wants to be divided, we can, or immediately I guess, we can ask for this, the sign. And then we have to restructure everything. I mean, dividing an interval can lead to the following. Say we have this with a, and we divide it, and we get a plus still again. It's the same as the thing had. Then now the one interval must become two intervals, and both must point to the same object. I suppose the first one can inherit the object. So this one still points to the same object. This one points to the same object. And if this was a +2, then it would also point to the same object. But because this is a minus sign now, which is different from what we had, that gives a really drastic change. Okay, that just means that this object that was pointing to that object, so this interval that was pointing to this object, must remove itself from this object. Yeah, so that's why this part is now gone. And we always end up with exactly this structure, plus minus plus or minus plus minus, which means that both now need two pointers. And then the first one, for the one that points to the left, it's not that easy. I mean, in this case it would still point to that thing. What if this one is gone as well? I mean, though it goes in steps, of course. I'm going to concentrate on this block here. And then perform one step after another. So let's say we begin with this. I'll copy everything for now. In a minute, I need a lot of these things. Whoops, not enough. Not enough things. That didn't work. So we have this, and then the first step is that the first interval divides itself and gets a plus. Then we did not divide this one yet, which means that we have a big contiguous thing. Three intervals now that all point to the same object here. Or this leads to a minus sign. In which case, this is not here anymore, and this is not here anymore. This got shifted over there. Okay, let's see. Yeah, other possibilities don't exist, it seems to me. So we always only have one object left now. Here's one and there's one. Yeah, the difference is that in this case, if we divide this one, it's not exactly the same as dividing this one. Because here the object spans everything, and here it extends to the left. So if you figure out how to deal with dividing a single interval with the same signs, where the object that is above it either spans it completely or extends to the left or extends to the right or extends to both sides, then I think we covered the whole algorithm. So I would still have, of course, I have to deal with the dividing an interval that's as a plus and a minus. Okay, that's an orthogonal to it. So let's describe it as follows: dividing an interval that has equal signs. Case 1. So there's no first interval anymore, just one interval. However, I can move it over here. Case 2. Yeah, and then each has two possibilities. Here we find a minus, a plus or a minus. So yeah. Right, okay, now this, oh no, let's just start at the top. Here we only have the interval that we divide. Let's skip that. I want to just first see that there's nothing to change on the other part. So here we have an interval that we do not divide, and it is pointing to this object. And here it's still pointing to that object. So, but yeah, that's okay. Just the extra intervals now point to the same object as well. Here we have this object. This interval was pointing to this object. I mean here. And here it is still. So we just have removed this interval from that object, but for the rest, one object, one object. In case 3, well, that's symmetrical. It's just on the other side. So this one points here, and here it still points to that same one object. And here this also, just these two, this interval removed itself from that, and then nothing was added. And here both were added. In this case, however, we have one object here, which just gets extra objects, intervals that point to it here. But in this case, the object is split in two. So now I really have to make a change to intervals other than ourselves. This one and beyond. So I can say leave this interval alone. It just points to its own. And then we have to remove all the other objects from it. And create another one, a new object that then all the following intervals that has to have the same sign are re-added to. So that's a bit involved. Otherwise, it's only about the old and the new, the old interval that is going to be split, and the new intervals that appear afterwards. In which cases we do the following. It was already pointing to an object, and now, yeah, we have two that points to it. This is wrong. Don't have anything anymore. So in the case of a plus, I can reuse this object, this interval, for that one, and then add another with this pointer to the same object. While in the case of a minus, I suppose you can also reuse the same object, but you have to remove the pointer and change that into a minus. Here as well. Both cases, a new interval has to be created though. Inserted in the list. Same here, and just let's say always the second part is the one that is inserted, then the old one is still pointing to the correct object above it, and this one just adds it. In this case, here we change the end sign to the minus, change the size of course, remove the pointer to that object, and we have to add the pointer to that object. Which is the same point. This is the same object because this one is being reused by that. Maybe we should give the objects an explicit name so I can keep track of which object is being reused and which are new. So let's call this one, now yeah, what shall I call it? Other than, it started with P, PQ, etc. So this is still P. And this one is pointing to, let's say, pointing to P. This one is pointing to P. This one is pointing to P. This has 2 pointers, both of which are 0. 2 null pointers. That's not true. Well, this one still points to P. That is P. And this is then nothing, 0, 0. This is P, still P. Yeah, in this case, just a one object, so that must be P. This one is pointing to P. And that one too. Yes, I think I have them all like this. Do I want this object to point back to all the intervals that are part of it? Probably not. I do need to know the size, however. The first and the last interval kind of are required. To make it a struct, it's hard enough as it is. Don't want to be bothered now with accessors and all whatnot. So I have begin and an end. I'll call them underscore though, even though they're public now. Yeah, so this thing here is are these arrows here on top. And I just keep track of the number of intervals they have and the beginning and end value. So I know the size of them. Got the feeling that should be enough. So the very initial one is then created from the original range. For example, and that then sets begin to x range min, and the end to x range. I would seriously call that a min and max range. Yeah, min and max. Yeah, okay. The thing also has a size in the center, so maybe I should use range to begin with. I'm going to use range here. Call it span, so it spans multiple intervals. Wait, I don't need the center. Oh, but okay, I need the size, so whatever. It should work, and then the number of intervals is obviously 1. The very first call, construction. And then we have the intervals themselves, which are these things. Which have yeah, a begin and an end sign, I suppose. And then we need a union with pointers, but what was the replacement of a union these days? Standard variant. No, it's just silly because in both cases it's a pointer. I might as well just use one pointer. Gosh. So a pointer to an interval span. I call those first and last. Might as well make it a pair then. So the first one is either this, or the first and second are that, depending on if it contains a sign change. So now we have the signs and we have the pointers, and I still need to know the begin and the end value of the range, which I can also call a range, of course. Yeah. Now the thing needs a constructor as well. In the beginning there was one interval which has an X range. That's it. So then interval is of course that X range. Maybe I should call it X range here as well. Just the whole class already called interval. Let's call this just the X range. And the begin sign is, well, I had a function for that, right? Sign of derivative at x. Yeah, and then the nasty thing. Why the hell does this not indent? Ridiculous. Let's put it there. Because we still have that thing. How do I initialize that? It does not have an interval span, right? At the moment you have just... wait a minute, actually. It does. Yes, of course it does. If the signs are equal, then we have an interval span. So just one. One interval big. Too difficult for the initializer list, so I think let's do if contains sign change. Let's make this thing empty. I mean, it's already using the default constructor. I'm not 100% sure it's using null pointers. Probably, that's all. Now we have an initializer list. I could add it here as well, but why not like this? And then that's okay for if it has a sign change. So if it does not have a sign change, then I want to change the first pointer to be a new interval span, which we have to initialize with the same X range, and that should be sufficient. Oh. No. Okay, I'm going to turn it into a class. Why not? This one not yet. Okay, you're going to have eventually multiple pointers to the same interval span, adding and removing them. I suppose, yeah, well, we just need a counter. So I feel like using I never feel like using a shared pointer. I always prefer to use the intrusive pointer of boost. Which isn't as intrusive as it looks, because you just do here public utils. Oh, it's just even without utils, I think. Ref count. Which sits in no namespace. Yep. So we just do that. And then we can use this. You have to just assign it. New becomes new, assign the new to the intrusive pointer. With some export info, but don't have to read it now. Minute. So this is a part of utils ref count.h. Give me a second. It's hot here. There be light. I took my sweater off because I had it on and I went outside, and inside it's still 24 degrees, which is just dying. Now, I think yeah, now the passing null pointer is really nonsense. I mean, the default constructor of boost intrusive pointer is obviously pointing to a null pointer, to nothing. So you can now assign it and then safely point other stuff to it as well, and it works perfectly. Really nice, better than shared pointer in my eyes. The main advantage of this thing, I think, is that you can just convert it to a normal pointer, and then convert it back to an intrusive pointer, and no harm done. Plus, of course, the size of the pointer is just a pointer. Yeah, well, okay. Anyway. I think it's time to print a debug output for this very first interval. So here we have this intervals. We even have intervals still. Probably should have it. Interval. Okay, I have my own interval now, so this can be gone. This is then highly dubious. But yeah, in the end, you're going to need a list of intervals. Think about just making this an its own linked list, or maybe even singly linked. Because the only time I need to change something of a neighboring interval is here, and that's only on one side, not the other side. So the side on the left you can always ignore. So a singly linked list would be completely sufficient. And we always preserve the leftmost object. As you can see, we have a P here, and even if you split it, just the leftmost object points to the same thing that we had. Here to, here to. Yeah, here too, even though I forgot to add a P here. Of course, this P just continues to exist there. The first one here now always survives. Oh, there's one that did not survive. Yeah, because I wanted to reuse the interval span over there. See, that's problematic. Then later we want to split this one again and find a plus or a minus. Then we get again an interval with 2 times the same, so without a sign change. So I need again an object, which is then. Oh, wait a minute. I'm talking nonsense now. These things are not ordered. We were talking about these intervals. No, okay, nonsense. So here we have this one. This one is pointing to that one. Okay, so it's these intervals. So this object could have a next pointer to the next one. And then the question is, if we split one, can we just keep a single linked list? And I think we can, because we have the pointer to that one. We insert something here. So we just make this one point to the new one, and the new one point to the old one that this one was pointing to. And then we have it inserted, singly linked list. I'm not sure if the standard has a singly linked list. I don't think so. Let's make one ourselves. Why not? So then my interval has a pointer to another interval, if it exists. And that definitely begins with a null pointer. The first one does not have a next interval. And then we can just work with a single interval, which just survives. That is then, the first interval is then also our list. So I don't need a vector of intervals. My list is simply this first interval that we create. And therefore I call it intervals. And we have to pass x range to it. And then for debugging purposes, we're going to print it, which of course means that we just run over all the elements of our list, which is then going to be an interval pointer. Officially, well, I could make it a const pointer, right? Interval. While interval is unequal null pointer, interval is interval next. That then runs over all intervals. Of course, then I have to add a next thing here, which is pretty straightforward. I have the feeling that this pattern will work. So if the thing is const, then only return const pointers. You could just always return this because whatever it points to is not part of this object. So theoretically it's perfectly okay to just return the value that you have stored here. But intuitively I have the feeling that maybe in this case you want to do it like that, although it won't mirror in for this code. And then we want to print each interval, and then yeah, what can you print? I think we can print literally every. Just print it to stand it out. I think you can print the contents of everything. Just nah, let's just print the whole thing as follows. The out, DC notice. I'm keep using GDB. Continued. Control flag. To can say that intervals are being printed. And it's a list of elements. So let's just start with that. And then at the end we finish by closing it, and that should do it. And then each element, I do have a separator though, so we do DC continued. Sep. I do abbreviate this for some reason, because I use it very often. So We start with the separator, which is then defined as a character const pointer that is empty string. And immediately after printing it the first time, I set that to the separator value. Branchless, so to say. We do multiple assignments, but I never have to check if this is the first call or not. And then we print this thing. And I'm inclined to say I want it to print itself. But yeah, I have support for that as well. I can just do that, and then even this is an O stream then, so now I'm trying to write an const interval to an O stream, which then automatically will find an existing print on for me. I mean, if you want to use that too, you have to use my utils library. I've, in the meantime, so much support for printing stuff that I can't remember it anymore. There is a print using, for example, which is very, very complex. Print using. That's what I mean with complex. You can do something like print using, and then pass some arguments, and then that will print it to the O stream that you're on at that moment, using whatever arguments you pass. Yeah, I hardly use it anymore because I forgot how it works. But probably this works, for everything. You just pass something and it works. But okay, this is easy enough. So we just print it like that. Then that will be called. Okay, and then here I'm going to then print that interval. So that means, well, intervals. Let's make clear that it is an interval as well, so usually put braces around it. Now, yeah, I can just print a range. Maybe I should print the sign first, the begin sign first. And then the range, and then the end sign. However, since we print the whole list of the thing, the end sign is always equal to the begin sign of the next one. So this is kind of annoying to have that repeated then. I think I'm going to leave out the end sign. I'll leave it. And then I want to know which span it is part of. Yeah, maybe it wasn't such a good idea to use to let it print itself, because it kind of depends on stuff, right? I mean, I want to print the interval span, but I only want to print it once. Could use a custom I/O manipulator. And then write some manipulator to the O stream to tell it whether or not it should print the interval span, and then have that depend on whether or not we had a sign change. That would work. How difficult that is probably depends on how good my documentation is with regard to that. Don't really want to do it, however. Okay, let's forget about this. Just add a few accessors and then print the whole thing from down there. Maybe both. I mean, I can still use this for printing the list, but maybe sometimes we want to print just a single interval, and then of course that should be possible. I'm just adding accessors for everything. We already had next. I'll add my print on back for printing separate. Just all the detailed shit. I wonder if this works. I should have debug support for printing pairs and probably also for printing intrusive pointers. Not sure though. If it compiles, it will work, I say. We want to print next. Maybe just a pointer. Debug output. Okay, I think that just including debug.h, which are probably already included anyway, it's not enough, and we need also debug OStream operators or something like that. Nobody knows where that is or if it exists. I think I'm going to compile this and see what happens. Too few template arguments. A pair exists of two things. Totally true. True that. Yep, you know what? I'm gonna include pair. Was of course already included. Well, where's pair defined anyway? Is it just defined in pair? Or is it? I don't even know, man. Pair. Utility. Pair doesn't exist, probably. Utility, I already have utility included, but well, this file uses it as well. Again, okay, now it already becomes tiresome. I'm probably, as soon as I have a type this big, I do something like using span type. Could also do auto here, but yeah, I don't like auto. Prefer to use auto when you have no other choice. Of course, the type varies. Called the non-static member function sine or derivative, blah 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 blah. Yeah, for that we need the test function generator. For first argument, the last argument. So difficult. Pass it as the last one. Noem it's in constructor for initialization of intervals. Could have known that because I just changed that. I'm gonna just pass this, I think, instead of star this. So that would be this pointer. Valid operand, so binary expression, O-stream, const interval. So far for my print on, but yeah, that just means that I have to include the stuff here that I kind of assumed it was already included. Include utils has print on.h, and then the real problem is probably that this is missing in the global namespace. No, it did print a pair of boost intrusive pointers, so who knows? Let's call this thing. And here's our output. The generated function with this seed, by the way, looks like this. What we are after is just a fast way to find the minimum, the positions of the minima and maxima of this function. But almost besides the point. So how is this printed? Well, we have a begin and an end brace, and we have one element, which is then that element. And that prints, the range of that is the full range from -1 to 1. Let's see, by the way. -1 to 1. Okay, well, I normalized it already, by the way, so that's why. And the begin sign is -1 and the end sign is -1 because the derivative is going down here, and in the end it's also going down. The span has a pointer, so this is my boost intrusive pointer. It's not what I wanted. I did not want it to be printed like that. And the second also pointing nowhere, and we don't have a next element. Great, but the reason that it looks this shitty is because now I'm just printing the element and using the per element to print on, and that was not the idea, right? Nope. You wanted to make a custom list printer. That uses the accessors. So how shall we print our interval? Yeah, I'm afraid this is not going to work, really. I just need a boolean anyway. Aman, no, I don't do competitive programming. I don't feel the need to be competitive. So, yeah, that's my separator. continued. Otherwise I want to print, if it is the first, let's do the first. We want to begin with yeah, we'll already have that here. Sorry, I wanted to start with a brace, but no, let's begin with just the value, the starting value. So the position is the X range. It's going to print the X range min. Yep, I'm coding C++. I could use that as separator and just print the end every time, which means that you can also print it here and nowhere else. And I want to print the sign between parentheses. It's more than 2 months. I think I'm far over 4 months now in terms of finding the global minimum of a function. The end one is not printing the sign now. Yeah, could make another function for that, but let's duplicate it. Did not duplicate enough. We also definitely want to know which what the span is. That's the last thing, basically. So if we encounter something that has the same sign, so it does not contain a sign change, then I want to print the interval span, but only for the first element, or shall we do it for the last element? Yeah, first element. So if something print, well, that would be the something. Print the span. No, actually, this is part of the thing internally, because it depends on if the interval contains sign change, how we want to print it. Let's separate that out here. Let's print the span like this, between square brackets, I mean. If it contains a sign change, then we have to print two things, and if it doesn't, then we just have to print the first one. I think that for now I'm just going to look at the sign of the value. Okay, let me first get this span thingy. Just this, of course. Hey Felix. Let's just print the values. So the span first is boost intrusive pointer, pointing to sorry, the span type contains a boost intrusive pointer. So then first is something that points to an interval span, which has a range and a number of intervals. I want to know both, right? Just so begin with this. It's a struct. I'm gonna, I should add accessors. Shall I call this range or shall I call it span? It is a span, it's an interval span. But on the other hand, span is already mentioned here. I think this actually should just be range. Should have been range. Okay, so now we have range and number of intervals. Where the hell was I printing this? $2.17. Oh, right. Yeah, so when do I want to do this? Only when when the interval changed type. Let's say type is unequal last type. Change sign. Nope. What do I call that? Contains sign change. Much better. So this is a boolean that converts to 0 or 1. If I make this an int. So the first time we always print this, and then afterwards you only print it when the type changed from. Wait a minute. If the does contain a sign change, and then the next one is again So always want to, what was, okay, wait a minute. I need pen and paper. No, I don't need pen and paper. I need to look at my ASCII art. So the first time you always print it, and then I don't want to print it here, but I do want to print it here. And also do want to print it here. So this goes from sign changed to not sign changed. Then I don't want to print it, don't want to print it, I do want to print it, I do want to print it, I do, that all works. But here I do want to print it, and here I also do want to print it. And here also, and here also. So the only reason I don't want to print it is if the previous type was the same sign and the current one is the same sign. Pretty much. So I can make this now a Boolean. And then we can do if last type or type, which is then not a good name. This is like literally contains sign change. Never make your types private. Remember reference for const interval. It's not a pointer. No, span is not a pointer, that's correct. Now it prints that the interval runs from -1. You know what? Maybe it's confusing if you look at the different function every time. I think I did pass the seed last time or not? No, I didn't. Well, let's use this one. So that one looks like this. It still runs from -1 to 1, but now it has a positive slope here and there. So it starts with plus plus for the derivative. So it runs from -1 to +1. Well, that looks weird. And the derivative is positive. And the span has one element. And the whole span runs from -1 to 1 as well. I don't like the double bracket, so if this one is printed with, this is the range. If the range is printed with square brackets, then maybe I should use something different here. Like braces. What else is there? I'm going to use a comma here, but now in the end we'll get a whole series of this. Well, I still could use commas. I think I'm going to use a comma here. A comma here and braces there. Okay, so -1. Well, positive derivative means it's going up. So maybe I should just use a slash. Slash here and a backslash here. Derivative is going up and down. Yeah, so it says at -1 we go up, and at 1 we go up. Well, 1 is here. And the span is from -1 to 1 with a single interval. Yay, we got the printing done. Now back to the algorithm. Okay, what are we printing? We were printing kind of a list, but it's an interval. So there's 2 intervals. Let's just print a list here. In this case, I'm gonna just try it, you know, utils. I think I don't even have to use that. So I could do print using, and I want to print intervals, and then let's call this a print list. I mean, wouldn't you like this to work. Print intervals using print list, right? If print using is as complex as this, then it should work, I would say. And then this whole block is just really a member function of intervals, aka the type interval. Going to put that here. I should have indented it. Print list const. There's a huge chance that it won't work out of the box at once, I realize, but I always want to see how the error looks like. Yeah, use of undeclared identifier intervals. Oh, that's what? Here, okay, that's fine. This is not a problem. Yeah, we should use this pointer. See what else should change. Probably nothing. That looks good. Okay, and the other error was use of undeclared identifier print list. Yeah, that's a bit too vague. I have to tell it that it is a member function of interval. And that might work. Call to a non-static member function without an object argument. So that doesn't work. Why the hell does that not work? This is the call. I'm going to try one more thing, although that shouldn't have mattered that much. Oh, that's maybe a reason. Use of undeclared identifier print using. I thought it was including that header, and it wasn't in a namespace. Or rather, it is in a namespace probably. I thought that the out was including that namespace. Maybe nonsense. Probably nonsense. Still, yeah, it's in utils. Okay, let's use utils. No member name print using in namespace utils. Now what? Namespace utils print using. Totally is there. There's a header here. Utils print using. Here's one. If this is included, then it totally exists. Oh, I did not include it. Ah. No matching function or call to print using. Candidate function. Not viable. No known conversion from void to standard function. Candidate ignored. No, could not match. AKA against It wants a member function that has an O stream. Oh, right. That makes sense, I guess. Yeah. Yeah, that makes very much sense. Everything wants an O stream. Okay, so that's what we do have to change then. What is it now? Print list. Oh, print list takes an O stream. And then we just have to print to that. Yeah. Yeah, that way it's faster if I just do it like this. If I can't even type. Substitute the out continued. Hell, I might as well do anything. Wait, let's put that between. Do I do that like this? I don't even know. There you go. Could have been a million lines. Oh, yeah, that doesn't work. That would also not have worked with the dout operator. We're missing our finish now. Great. Or rather, I should not have used continue to begin with. Yeah, finally use the print using for once again. Same output. So, okay, algorithm. Here's the algorithm. What was the algorithm? Our algorithm is as follows. We run over all existing intervals. And then per interval, we decide if we want to divide it or not. Yes. If we do not want to divide it, we go to the next interval. If we do want to divide it, then we do this. Either case 1, 2, 3, or 4. So, well, let's begin. Where was I? Where was I? Where was I? Oh, here. So we run over all intervals. Oh, that's the same as I already have here in the printing thingy. And then it's like, if we want to divide it, then divide it. And otherwise do nothing. When do we want to divide it? We want to divide it if well, that's a tough question, so why not leave that to the object? Interval must be divided. Is that a form of procrastinating or? Yeah, LD, yeah. Well, I've done it my whole life. When I was really young, well, really child even, I just used my brain the whole day long. It's just me. Now I get way sooner tired than I used to. When I was a teenager, it was completely normal for me to have red ears, because warm red ears, because I used my ears as cooling fins for my brain. I didn't get tired. True story. Now I have headphones on, so I don't have cooling anymore through my ears, which is sometimes really problematic. But yeah, I'm not thinking that hard anymore. That's not that problematic. Yeah, I started programming at 12, but I was already thinking before that. I was always occupied with some problem. I did build stuff like I think even before I started coding. So that was before I was 12. I had Fischer technique. It's a kind of see if I can find that. I think Fischer technique, yeah, so Dutch images, this kind of stuff. No, that looks like what I was building. At some point, I made something that would generate a magic square. Seriously, it would just move, just over a paper, and then point in turn at where you had to put the 1, and then the 2, and then the 3, and then the 4. Purely made with switches, motors, of course, switches and relays. And I never thought that was special. Just interesting. Okay, so we were lazy. Yes, it's well, not really. I think this is a pretty nice way to do it. It must be divided. Let's assume that already exists, because what goes here? Tough. Okay, I'm gonna do the same thing. Split to the maximum laziness. I think this code is not going to be sufficient. I'll probably have to add something, but I will discover it when we try to implement this. Let's begin with the must be divided. Well, let's begin with split and just print that it has to be split. So I need an interval split. That's definitely not const. And then we print just entering or something. Entering interval split. No, I'm just going to print it. Sorry, just going to print that it has to be split. I need a debug channel here. Well, I always use notice. So there, that function exists. And then another function, which is going to depend on this. So let's... No, the question was, do we have to divide it? Huh? So what was the name? It's a boolean. It's must be divided, I think I called it. It's const. So when does something has to be divided? Well, let's do it with an if, otherwise it becomes a bit too much on one line. So this differently. If it does contain a sign change, then I don't know, so I'm just not going to split it at the moment. If it does not contain a sign change, then we must split it if the size of the range of the interval is they're always equal, right? I was just going to look at that value. So if it does not have a pointer, wait a minute, it has always a pointer. If the sign is equal, it always has a pointer to this object, which was called in the interval span. The span and then the first one. That's then a pointer to an interval span, which the interval span, where I can just call number of intervals on it. Less than 4. Is that not correct? Yeah, I think so. So now let's turn it around. So I make this because this was so short. Otherwise, we do have a sign change, so maybe you can write this one as well. If we have a sign change, then we must split it if I wanted to split it if this one had to be split or this one still has to be split. But I would first split this one and this one, so we would already have that. That's why I have to delay it, I think. So I would... No, I don't want to delay it. Okay, I have a problem. If the first interval is on the edge of the total range, then we have a null pointer to that side, which cannot be a reason to want to split it, because then we keep splitting and splitting and splitting it, right? Or can it? Oh, yeah, why not? We just want to start with 4 pluses and the first one. Okay, so that is a reason, because in this case we have 2 intervals with the sign change, so I have a null pointer from here to that side, which means that I do want to split this one, I guess, because yeah. So I want to split it if I have a null pointer, or if we have a pointer to an interval span with less than 4 elements, and maybe in this case less than 2 elements. Or not. I could, in this case, not split this one because maybe this whole thing survives. In which case we have 7 of them, which is more than 4. Why do we have 7 suddenly? Because you had 3. Now I'm confused. What the hell do you have 7? Oh, this one is added. So I did split it in this case. So if we would not have split it here, then we would have 6. Would have had 6 here. Which is also more than 4. Okay, 6. Yeah. Okay, I'm gonna do one last thing. So delay this one loop. So I want to split it in this case if it's not span first or not span second or span first number of intervals is less than 4 or span second number of intervals is less than 2. But also, I think about it, if the size of the thing is larger than the minimum distance left or right, in the case they are stopped. So it's more like if true or split, and otherwise it depends on the size. So if our own size, so that is then the interval, right? Interval, the size of the range is larger than the minimum of the sizes left and right. So these now exist. Divided by 4, no, divided by the number of intervals. So I might well just ask it, I guess. Interval size. The second interval size. So then the interval span must have an interval size method. Let's see. Yeah, that should work. Number of intervals, at least one at all times. My interval is const. Well, you can't split a const interval, so let's make it non-const. It doesn't print that it has to be splitted. Okay, that's shocking. Oh, it does. Yeah. Just was the line was a little longer than I expected. And then it prints this. So yeah, the only interval that we have. Oh, this is still printed in a bad way. Needs to be split. Yeah, to fix this, I want to just see what it points to. Seriously. Span is the span, thing is a pair. A pair with boost intrusive pointers, so Oh, can't print interval span. Good. No, I have to implement split, I'm afraid. Let me just copy over the comment that I have. It's a bit much though. I didn't even analyze yet what to do when I have must split an interval with the unequal signs. I will. No, that's not what I wanted. Let's shift to 15 down. 2, shift, 15 down. Nobody gets it. Case 1. Okay, well, if you must split it, then definitely want to do is find the midpoint. I'll follow Claude's example of calling it with an abbreviation. I hate Claude. It made me use abbreviations. Mid is... Do we have a range? Totally have a range. The center of the range sign is gotta be kidding me. You need access again to test function generator. I really hate adding something that is the same for every object. So we could add a member here that is just a test function generator pointer, but then every interval object will have the same pointer. It's so no. And if you're now thinking about, well, add a static, then please leave my YouTube to never come back. I'm just kidding. So I'm going to pass it. Again and again and again. I'd rather pass it 1,000,000 times through functions than to add it to every object. I guess I'm memory safer or something like that. And then, of course, nobody knows how that function was called. Something with Okay, I believe I wrote all this in one day. Can't find it though. Something with sign. Sign of derivative. The sign of derivative at the midpoint. So case 1a is when this is has the same sign as that, so we need to know what this sign is as well. Let me call that left sign or something. What the hell? Where do we get that from? Oh, that's just that's simply begin sign, dude. I don't need to make that a local thing. Okay, case 1 means that there is nothing on this side. I'm not even sure that ever matters. I mean, it does matter if there is something on the other side, and then only in this case. Right? Because yeah, we're just going to do, we have PP and we're going to replace it with NN. Oh, sorry, I had P and then in this case PP or NN. And in case 2, we have P and then it becomes PP or, oh, okay, it does matter. It does matter. Yeah, so I need to know if there is, not only do I need to know if there is something on that side. Well, in this case, but then we split that one anyway. Ah, okay. I think I see the light. We must know if our interval is the first interval of the span, and that's easy to check. We can just use the value of this x coordinate here. So I could say if the current interval is first interval, that would be that's case 1, and it's also true for case 3. So maybe I should start with the end. Then you have case 1 and 2 together. Nah, I don't care. So if it is the first interval and the last interval of the span, then it is just the only interval of the span, and then that's case 1. So then we have to implement Boolean is first interval. And I'm probably only going to call that for something that has the same sign, at least that I'm doing at the moment. Because yeah, I just need I need the first span here, which is only defined for the same sign things. Could add an assert, I guess. So then we can access this, which then points to, again, to the interval span, and then I want to get the range of that, which is this one. And then if that the start of that range equals our own start, which is of course that, then it is the first interval. And likewise for the last one, if we use the end of that, and it is equal to the end of that. So then here I have else case 3. I don't know, 8. Yeah, no. Okay, I give up. Yeah, I should have done 4, of course. I thought 8 spaces. So. Well, if it ain't case 1 or 3, then it must be case 2 or 4. Yeah, should just begin in the same way, I suppose. Okay, what's wrong with my indentation here? I'm an idiot. Da-da-da-da. So if it is the last interval, there is nothing after it, then it is case 2. And otherwise it's not the first and not the last, which means it's in the middle, and therefore it's case 4. So that's a get case too. So now again 16 down, and then I'm gonna count it. 1, 2, 3, 4, 5. And then case 4. Might as well delete the comment here because it's just 100% duplicated. No, okay. Now we know exactly what the situation is, and you have to split it, which means that the current interval must get added or inserted must get inserted in an interval. So yeah, I mean, current one, insert, new, interval, and it must point to the same should could just pass a boost intrusive pointer, I suppose. So span first. can do that automatically, I suppose. Increment. The interval is created with p, which means that p must be incremented, right? I have to pass more though. I have to pass the new range as well. To the begin and end point, I can just this is the midpoint, and then the end of the current range. As well as the signs. Call this append. No, it is a insert after. I don't know if I ever need an insert before. Oh, it's not possible because it's singly linked list. So let's call it insert, I guess. Okay, now I have to implement this constructor. That's construct of interval. This is interval. Let's add a constructor here. Yeah, I have no idea, man. I stopped with Vulkan. And I don't know Rust. I think Rust is sort of a hype, so I'm kind of sick of it. Well, actually, no, you should stick with C++, yeah. I mean, the Vulkan engine needs to be extremely fast. So you don't want to have all those... oh, let's protect the programmer against being stupid test and I don't know, whatever, what Rust did. Speed is more important than safety in this case. In the case of a Vulkan engine, I would say. Besides, anyone able to write a Vulkan engine is really smart enough to not make the mistakes that Rust protects against. I never have memory problems. think they invented Rust for the dumb programmers, the ones who can't code without introducing weird bugs. Yeah, try that with standard shared pointer. So I just converted my intrusive pointer to a normal pointer. And now I pass the normal pointer again to intrusive pointer. And it just works. But okay, this was just my personal preference, as it were. Yeah, I might as well set it to 1 in here. Just wanted to set it to 1. Okay. But then how do I make sure that is the case? It means that I have to decrement the number of intervals before destroying the boost intrusive pointers. That's not gonna happen. No, nonsense. Wait, actually, no, not nonsense. Think about it. Yeah, the whole test is nonsense. We only construct and add stuff, except at the very end of the program, then I destroy everything. And seriously, I don't need this assert then. We do need a decrement though. That's the X range, the new X range of the new interval. With correct signs, and this P here is being passed, and then that we pass that to an insert that I still have to write, and then the whole list is completed again. Plus this constructor calls increment on P. So before we had just one, and now we have two elements. And then what you also have to change is the current object here that should decrement its range. So you have to adjust the X range and to mid. And also change the sign. The inside of the current thing becomes a mid sign. Although we are in this case and these two are the same. So actually that's not needed because there is no change there. How to change the endpoint of the X range? I have no clue. Let's look at range. Other range. This range. We can't. Can only reconstruct it. Okay, so I'll just reassign it. I think the compiler is smart enough to see that this only assigns mid because this is the same memory address. This is inline, so it knows that this is the same memory address as the first thing here. So everything combined, everything is in line. It's just going to assign mid directly to the end, I think. Speed freak end. Okay, so that's it, isn't it? Well, the insert now, of course. That's a nasty one as well. So this insert is past a pointer to an interval. No, this is an interval. Let's add an insert somewhere. Something like that. It looks a bit weird though, because, well, you would like to automatically update all the other variables as well then. So this inserts something with a known range. I can read that from this new interval. So I might as well change the range here using whatever the new interval is. Probably better. So instead of doing that here, the only thing I was doing is changing X range. Should change the signs as well. Even forgot that. So the new X range becomes blah blah, where mid is actually the beginning of the new interval, which is a pointer. Let's see if we can access these things directly. And we're leaving the span pointer alone, huh? That was the whole idea, huh? And the begin sign and the begin of the range does also not change. So this should be okay. And then of course P is P. Sorry. I wanted to move P over here. P is always P. I mean, P is just, I mean, that's what we begin with. Can move that even up here. No, cannot. So we do no sign change, then the first pointer of our pair is pointing to the span. Oh. Can I make that const? Because it's so much comment that you can't see on one monitor screen if P is going to be changed later on. Otherwise, you have to. Is P is assigned here? Is it changed later? So let's say now I can see that that's not, that it is not being changed later. Now let's test this. I'm going to add assert false here to make sure that we don't get here. Not implemented. Reference to a non-static member function must be called. Too few arguments. Function. And extrema. So, oh yeah, this is just this, isn't it? Core dumped. False failed. Well, exciting. My brain was screwing with me. What are the arguments now? Do we have an argument? Yeah, we have an argument. See, that's pretty awesome. Well, I would say, why do we get here? We have only one interval. I'm just going to have a set a breakpoint here. Run it again. So intervals is our only interval. It has a next pointer of 0. How can it be blowed? Every line is doing something, and there is no way to compress it with a magically compress all this intelligence of the program in less code just by using a different language. It's pure nonsense. Interval must be divided. Yeah, I guess that was a yes. Does not contain sign change. No. Return number of intervals less than 4. So you're also 12 years old, I think. Grow up. The number of intervals less than 4. Yeah, the number of intervals is 1. So let's just finish. Then we can step here. We get at interval split this. Not in the mood. The minute. To print mid. Mid should be a little 0. Yeah. The sign of the derivative. Oh, I'm an idiot. Yeah, of course. Sign is not the same. It's just a random function. Begin and end sign are both 1, and if this is also 1, which is a more coincidence, then I don't understand why it is asserting. I don't. If it not contains sign change, well, it doesn't, so we should get at 170. The interval span is P, which contains the range and the number of intervals. Yeah, well, that looks correct. is first interval. It should be the first interval. So maybe that goes wrong. It should be -1. And it should be -1. Therefore, it should return yes, true. Return true. So we get here. Here's last interval. It should also be the last interval. Step. Well, that was 1. Just print it. And this is 1 as well, isn't it? It's also 1. So I would say this is also return true. Also true. I think I just forgot. No. What? Yeah. This should also be true because both were 1. Insert must be something extremely stupid. The insert that I ran into. $90 next. The 99. Return. Oh, I inserted, yeah, I inserted something. Okay, I'm getting it. The split inserted a new interval after the current one. So next now is not 0. Dang. Yeah, we want to do everything one at a time. So the inserting is all nice, but I really want to set interval to the next value that was the next value before we split it. That should work. That should work. I tag in. Doing this. Quit. Yes, we are. India. I should be going to bed really soon, unfortunately, though. Let's call this next. That ain't working unless I do that here. I'm not sure if I want to. Let's do it anyway. Just looks silly, doesn't it? Okay, it escapes me for a second. If I set the next here, so we do interval star and then, oh, that doesn't even work. I have to add 2 stars. Ah, this is too ugly. I don't want to do this. I'll just put one outside of the scope. So we make that the starting point, and then yeah, I still have to test that one. Maybe we should not do this either. Maybe we should make this one next. I still have to initialize it. I would prefer to do this inside the loop as well. Oh wait, I know what next is. The first next. The next is simply null point. So we can initialize this as to null pointer. And then we can do this here. And then the question is, which is it guaranteed that interval is assigned first here? And then we do that. I'm not sure actually. Can do this. Oh, we can do this. What am I doing? Is it caps lock or just my fingers wrong on the keyboard? No, and then we crash. That's definitely not what we want. Well, it should be the other way around. So hopefully this is done first, and then we can assign that. No, I first want to do this, and then change the next value. So this is how it should be. But then we crash anyway. I only want to do this if that is true. So yeah, forget it. Forget it. I should just. I'll just have to do it like this. There's no other way. Okay, let's try this. think it worked. It's a bit hard to read, but it says at x coordinate -1, the function is going up. That's correct. And at index 0, it's also going up. Well, that's indeed also correct. And then it's printing the span. And the span is printed after we have 2 of these, because the sign of both are the same. Well, they're both going up. So we have an up, up, and then we print the span, and then we see that the span contains 2 intervals. It does not run from -1 to 0, it runs from -1 to 1, and it has 2 intervals. So this is the first interval of that, and the second interval is from 0 to 1. At index 1, x coordinate 1, it's also going up. So it's up, 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 plus, 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 and we have a single span here. Okay. And I think it's unreadable. It would have been nicer if you just start with this and then a column and then the 3 that belongs to it. Or maybe the other way around, in which case I should just continue doing this until I find something that is not going up. Yeah, just printing it as soon as we see 2 is just too confusing. I mean, I can deal with it, but it would have been nicer if it just printed it a tiny little bit different, which means, where's the print list? Currently printing it at this point, but I want to not do that. I want to delay printing it. Okay, so and then we print it as soon as we see something that is no longer having the same type. Isn't it like that the current thing does not contain a sign change? Yes. At least it looks good now. So the span is from -1 to 1 and it contains two intervals. Namely from -1 to 0 and from 0 to 1. All going up. Then we do that again, and now we assert, of course. We assert on case 3. Well, let's implement it. Oh, it's still the plus, so it can't be that hard. Oh, wait a minute. It's not. I don't know if it's a plus or not. Let's move the asserter down so we know which one to implement first. Oh, this one. Well, that is a plus. So we're going to, this is the current interval, and I want to insert this one pointing to P. Nothing else has to change. This is just it. I think it's going to point to P. It's going to start at the midpoint and at the end of the current range. The signs are belong to that. Takes care of incrementing the count. No problem there. Unfortunately, you also have to insert a minus. I think insert can take care of everything. I mean, all the information is there, and we can detect that it is this case from the fact that mid sign and end sign are different. Not to mention that they are different from our own. So this thing is different from our own. So this one was already a null pointer, even though I just use P, the other one is a null pointer, so this doesn't even have to be changed. The only thing that changes is that this one must have a null pointer now. Let's see what else we have in case of a minus. So then we must have double ends. So here definitely it does must be reset. I'm not too happy to move all this to insert really, because yeah, we have our all the explanation here. So I'd like to see the logic coded here and not inside insert. That would be a bit confusing. So maybe I should call, yeah, well, I'm still having to do insert though. So what does this insert exactly though? This just inserts it. That's definitely still okay, the same. The X range is set to, yeah, the new is also the same. End sign also the same. So this whole block is perfectly okay. I think that anything extra has to be done by either the calling code or the constructor of the new interval. So in this case, that needs more or less special treatment, and that I should pass a null pointer. And this one doesn't have to change here because I know it's already PN. Let's see, it's either NP or PN. So yeah, even passing 2 pointers is kind of nonsense. So, well, actually it's NN, PN or NP. It's obviously never PP or PQ or anything. I have an NQ, but then I can just pass the Q. So I can pass a pointer, and then probably I should just say if it is left, right, or none. So let's pause here. It's actually none. So constructing this thing, we don't need a P at all. Now, you could say maybe I should just pass a null pointer. Okay, I'm doing that. So a null pointer means none, and then in some cases I might want to pass. Yeah, I can already do the others, can I not? So in this case, it's exactly the same as the others again. All the pluses are probably the same. So if the signs are equal, then yeah, this is it. PP. Same here. It is the same. And the same here. And the same here. And then the null pointer is the same whenever I only need to change the second one to NN. This one is special. Okay, this would be NP. This is also NN. Oh, actually, yeah, it's a little bit different, but I can insert an NN and then I have to set the span pointer to null. And to make this P and N. Oops. That was a P. And now it must be an N. How many asserts are now left? This one. Actually, both lines are needed here. Right, so then what the hell? Oh, I need to call decrement as well. Forgot about that. But yeah, so if I pass null pointer, then we create one with null null, and that works. But it might also be null pointer p. Let's just create a null pointer anyway, and then assign p depending on the sign. So the begin sign equals the end sign. Then we'll say span first is p, else span second is p. And then this can only be done if p is not null pointer. And then I took care of everything, I think, except the calling decrement. So here, yeah, just setting this thing to null is not enough. This is the situation, and the p must be set to null, but that means also a decrement. Yeah, well, let's do that here. because if you reset it, then we must decrement it. Now we end up with the full span has 3 nodes, -1 going up, -1/2 going up, 0 going up. That's 3. And that is, don't you have a left null? What? Oh, that's that refers to an interval with a different sign, with the sign change, and I don't see it. Plus there's a comma here, which is nonsense. I did split it at, so we have -1, -1/2, 0, 1/2, and 1. And the derivatives are okay as well, I suppose. All of them are up except at +1/2. So up, 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 down, and up. Then what the hell does this mean, or why is this comma here? I think I get the comma, but yeah, okay. The left null means that we do have a pointer to the left from here, and we don't have a pointer to the right. But which interval is that then? Must be the interval between 0 and 1/2. That's nonsense. Okay, I'm very confused. Let me see the print list again. Comma, comma, comma. Let's call it what it is. Saw this thing, which is span. So saw span. So we just printed the span. So I'm going to say saw span is true. And then of course, so we only want to print a comma if we did not just see a span. And that's just actually simply determined by whether or not we enter here. So I wouldn't even need it. I can just do the same test as this. So if the current interval does contain a sign change, then show span is always true. Therefore we show the span, which then prints left or right or null or null. And then let's ignore this for now. And this is false, and then it's going to print just the maximum. Yeah. So the sign change must indeed be from the previous one to the current one that is being printed. Still a fucking comma, joh. What is this one? I think, yeah, of course. See what this looks like. Yeah, okay. So I need space here as well. Okay, so we have 3 intervals. That is, and now there's a comma missing here. 1, 2, oops, 3 actually, because it's going up and up. Oh, what the it's just too late. I'm going. I mean, I could continue with this forever, but I have to go to bed because it's almost midnight and stuff. I'll fix this probably off stream and then continue streaming tomorrow. The printing of it. So good night.